Hello friends, welcome to my YouTube channel. My name is Prathmesh. Without wasting our time, let's begin. And if you like, please like, share, and subscribe.
Anthropic just released Claude Opus 4.7, introducing high-resolution vision, a deeper reasoning mode, and a specific system for autonomous code reviews. By the end of this video, you'll know exactly how to configure this model to run as a continuous workflow that operates with high accuracy. To build this setup, you need an active Claude Opus 4.7 account and a demanding project file ready to test. A quick note: Step 2 involves a new automation feature that Anthropic currently limits to the Mac desktop application. Windows users will need to skip that specific step for now. Properly configuring these settings enables the system to execute multi-stage tasks without the manual intervention required by standard chatbots. We'll start by uploading your materials. Open a new chat in Opus 4.7 and drop in your complex UI designs, dense documents, or presentations. Opus 4.7 features an upgraded vision model that reads and processes images at a significantly higher resolution than previous versions. Before sending the prompt, look past the main chat box and open the Model Settings and Parameters menu. Locate the toggle labeled Extra High Effort and switch it to the On position. This setting tells Claude to allocate more raw compute time to your specific prompt. Giving the model more time to process the problem ensures a higher level of accuracy when it tackles difficult reasoning tasks. The combination of high-resolution visual data and increased compute allocation allows the AI to systematically work through dense architectural problems or complex codebases. For the second step, Mac users need to leave the Claude interface and open the Mac OS system settings. Scroll through the application settings to find the row labeled Auto Mode Permissions and toggle it on. This grants Claude the system-level permission it needs to make specific technical decisions on your machine. This change eliminates the need for the model to stop its progress and wait for manual approval to proceed to the next step. Bypassing these frequent permission prompts enables the agent to process long, background-heavy workflows from start to finish. With the system configured, we can head into the Claude code interface for the final execution step. Enter the command Ultra Review to initiate the agent's analysis of your uploaded files. This mode performs an automated code review, scanning the work to isolate deep-seated bugs. While this runs, you will need to monitor your background usage dashboard. This chart shows a change in text processing. On the left, the previous version breaks text into large tokens. On the right, version 4.7 fractures text into dozens of smaller blocks. This higher density means prompts consume more volume, causing usage budgets to deplete faster. Because these autonomous modes process data so densely, the high-effort settings should be deployed for your most critical tasks to manage costs effectively. You now have a configured, autonomous workflow ready to deploy for high-stakes projects. Using high-resolution document processing and the new extra compute mode provides the depth needed for reliable results in complex technical tasks. With the Mac system permissions active, the agent carries out the work in the background without requiring constant user input. You can test this setup on a high-stakes code review or document-heavy presentation to measure the time saved. Integrating these vision, reasoning, and permission updates moves Opus 4.7 from a conversation partner to a system that handles urgent, multi-step technical labor.
For years, the standard interaction with a large language model has been strictly reactive. You write a prompt, and the system generates a static output. The latest update to Anthropic's Claude introduces a self-correcting, autonomous engineering loop that actively reroutes itself towards a solution. The historical bottleneck for AI practitioners has always been the interface. Conversational models stall the moment they complete a single instruction, sitting idle until a human manually prompts the next step. The release of Claude Opus 4.7 marks a deliberate pivot away from that conversational constraint. Opus 4.7 introduces the underlying system architecture required for unbroken, agentic software engineering. This architecture is built on 4 mechanical changes: an extra high-effort inference mode, an integrated ultra-review command, localized auto mode permissions, and modifications to its tokenizer dynamics. For software engineers and technical product managers, these new capabilities shift the daily workload toward the orchestration of autonomous systems. Utilizing this effectively requires treating the model as an autonomous compiler. Mastering Opus 4.7 requires looking past the surface-level UI updates and understanding the hidden computational pipeline orchestrating these new features. Standard large language models rely almost entirely on their pre-training data to generate near-immediate outputs. The system receives your input and probabilistically guesses the next word without pausing. Opus 4.7 introduces an extra high effort mode. This utilizes a mechanism known as Inference-Time Compute. This diagram compares the two generation methods. The top path is standard generation, prompt to immediate output. By giving the model more time to think before returning an answer, the system creates an expanded latency window on the bottom path. Within this window, the system dynamically allocates compute resources to explore multiple, diverging probability pathways simultaneously. The model continuously checks these intermediate reasoning steps against its internal logic. Failed branches fade out, while the successful logic paths converge into a single, highly pronounced output line. If you assign a complex engineering task, like optimizing a large-scale database query, the model is no longer taking a single guess. It is generating multiple query structures and internally evaluating their efficiency before showing you a result. This process of internal branching and verification directly reduces hallucination rates in logic-heavy workloads. Scaling compute at the exact moment of inference was previously too expensive and slow for standard consumer-facing API interactions. It yields accuracy rates that outpace standard prompt engineering techniques, like forcing a model to print its chain of thought into the chat window. Trading user-facing latency for structural accuracy expands the category of highly technical tasks you can safely delegate to the model. That internal reasoning capability only handles the logic. The next requirement is managing external code generation. Generating unverified code carries the risk of subtle syntax errors, historically requiring a human developer to step in and manually review and debug the output. Anthropic addressed this inside the Claude code environment by adding a new Ultra Review command. This flowchart illustrates how Ultra Review operates. It functions as an integrated feedback loop between generation and verification. During review, the system evaluates code diffs, enforces architectural standards, and isolates logic flaws. Rejected syntax blocks are automatically routed back to be rewritten. It functions as a simulated native CI/CD pipeline, running entirely within the AI's local environment. Mechanically, it mimics the behavior of a senior engineer conducting a rigorous pull request review before allowing code execution. This native verification loop shifts the human user's role from a line-by-line debugger to a high-level systems orchestrator. Even with a flawless internal review process, the system stalls whenever it requires a system-level action. The core friction point in current workflows is context degradation, caused by the model constantly pausing to ask the human for permission to proceed. Look at a standard multi-step task: read file, write script, execute test. Between every operation sits a solid barrier where the AI must wait for mandatory user permission. The macOS Auto Mode Permissions update solves this. When activated, those permission barriers dissolve, allowing a continuous, unbroken line to connect the entire sequence of operations. The model is granted the localized permissions needed to navigate directories and execute command line instructions autonomously. If a command fails, the model handles the error autonomously, feeding the terminal output directly back into its own context window to attempt a fix. The technical term for this capability is long-horizon orchestration. Removing localized permission friction is the final architectural requirement to trigger fully unbroken agentic software engineering. With autonomous orchestration achieved, the primary limiting factor shifts from technical capability to operational unit economics. A critical caveat exists in the update notes. Anthropic changed the underlying tokenizer for Opus 4.7. A tokenizer dictates the mathematical mapping of raw text strings to computational tokens. Here is how historical prompt libraries and codebases are processed under this change. Two distinct scanning algorithms pass over two identical blocks of code. The exact same string of text yields different results. The first scanner outputs a standard token count. The Opus 4.7 scanner outputs a significantly higher token density for the exact same data. This higher token count naturally inflates overall API usage costs for identical workloads. Anthropic's pricing per million tokens may look static, but a flat rate applied to a denser token output means your actual expenditure increases. This increased density is a direct trade-off for improved reasoning. Parsing deeper logic requires a more granular token mapping. Technical product managers now face a direct calculation, balancing the engineering hours saved by agentic workflows against the inflated API expenditure. The true skill in leveraging Opus 4.7 is auditing engineering tasks to determine which specific workflows justify the higher token expenditure of the new architecture. Let's review the comprehensive mental model we've constructed. This diagram shows the unbroken flow from user prompt through inference compute into code generation, the ultra review loop, and finalized by auto mode. Now we integrate the final update. High-resolution image understanding adds a new, distinct input node to the pipeline. This visual input expands the scope of the agentic loop entirely beyond pure text and code. You can input UI design files, dense document presentations, and architectural screenshots into the pipeline. Based on the source material, Opus 4.7 is optimized for urgent, document-heavy agentic engineering work, a system that can ingest static designs and autonomously write, review, and execute code alters the daily trajectory of a software engineering team. Opus 4.7 serves as a definitive step toward AI as an autonomous engineering partner, provided you master the architecture and the economics driving it.